gonna be our turn with the session 2, in which we will look at cross-cutting issues. And we will start with two wonderful ladies, Nuria de Lama and Aurora Ramos from Atos. And they will talk about cross-cutting issues, in particular data spaces, processing, and networking. Nuria, Aurora, the floor is yours. I don't know in which order you will take the screen, but you.
Thank you very much, Monique. I will start. It's Nuria here. I will share my screen.
Hi, Nuria.
Can you see it now?
It's coming. Yes. Yes, perfect.
Okay. So we have tried to be a bit original. So basically we will make a combined presentation, both Aurora and myself. And one of the reasons is that precisely we are in the area of cross-cutting issues. So we think that it is important to establish links with different technologies and different disciplines. Many of them have been mentioned in the very beginning of today's session. And I myself, since I'm more involved in the data aspects, I will establish some links with basically with the data spaces and artificial intelligence, while my colleague Aurora will go more into the details and especially linking with networking and connectivity aspects. So let's go directly to something that is quite important to consider, which is convergence. I think that Max, in the very beginning of today, made a speech involving a lot of different technologies, and I also want to build a bit up on that. Let me use some of the sentences made by Thierry Breton, European Commissioner for Internal Market, and also former CEO of Atos. So you will see that the vision of Atos is quite similar to basically the values and the messages he's providing for Europe. Something that is mentioned in the first sentence that is quite important now is that when we talk about IoT, in the end, if we really want to be successful in the market, means being successful in the platform economy. And something that we have seen in the past is that basically American companies have been able to win the battle of personal data because they were able to establish very large data lakes, which we didn't manage to do. There is still the opportunity to do some of the things in personal data, but especially a lot of things regarding industrial data. And here's where IoT plays a major role. But of course, we cannot talk about IoT without talking very much about creating these data lakes. And in many cases, it is what we are discussing now as common data spaces. And finally, access to data has a value because it's machine learning and artificial intelligence applications, which are the ones that will really provide an economic impact on the different sectors of the economy. So the relationship with IoT is basically that most of this data will really come from IoT devices. And there you see that almost 90% of humanity's data will come from smart objects in 2025. I think that the percentage is already quite big, in fact. And I think that also Max mentioned this before, that now we were using a lot cloud, then it will be more the edge. I think that we are not still in these percentages of 80-20, but by 2025, it is expected that basically 20% of processing capabilities will happen at the edge. And that is why it is so important what we are tackling today here. Let me tell you a bit about what is our vision in Atos, and also trying to link a bit the past, what has been done in research and also in deployment projects, and what we can look at in the future. I think, or we think, that IoT is already a quite mature technology. We've seen a lot of examples in the previous session about the societal and also the economic impact of IoT. So I think from a technology point of view, many of the things are mature. However, even though we've been working in the past in many challenges, some of them still are not fully resolved. And I would like to highlight specifically the one of platform interoperability that has been mentioned before. Maybe still too many protocols, too many technologies, too many different kinds of devices, finally leading to silos when it comes to operate with the data that they manage. And then still a lot of security and privacy issues. I think it was mentioned before that the fact of doing things on the edge can be good also for privacy and security reasons. Maybe it's easier to protect privacy than doing that in the cloud. But on the other hand, not everything has been solved. And I think that still there are many technical challenges that have to do with this. I think that we've been working many years on these aspects. Still, they are not solved. So I would include them in the agenda for the future, precisely because they are not fully resolved at this stage. But looking a bit at the future, the way we see it is that basically we need to consider all these smart devices even as smarter things. So basically giving them more functionalities. And this means bringing artificial intelligence to the device. So how to do this, basically transforming data into intelligence. We think that we can start already with machine learning. That can be quite suitable for many of the scenarios where IoT play a major role. And of course, you know that this is basically detecting patterns and behaviors from the data that is gathered from the devices. So the more data you have, of course, the better patterns you will be able to extract. I think that when it comes to dealing with just one typology of data, is still relatively easy, and there are many technologies that have evolved quite a lot in order to help us. One example could be, for example, image recognition when you are dealing with pictures. And I think this applies, for example, to many scenarios in agri-food. What it is not solved at all, or it is not evident, as I say in my slide, is data integration. So basically how to deal with heterogeneous sources of data, and especially when you have to cope with structured and unstructured data of many different formats and many different sources. A lot of projects are there, but I think that this is still a challenge and is not evident at all. And of course, this is something that needs to be overcome. Then, even though it sounds still a bit generic, I think it's good to highlight some additional challenges also to trigger the discussion later on. You see on the right side of the slide that a lot of hardware already exists with AI capabilities on the edge. You have there some examples. Many of them come also from companies from outside Europe, also some from Europe. But still, there are many challenges we need to take into consideration to do machine learning or AI on the edge. One of them is clearly hardware performance. Another one is energy efficiency. And another one has to do with connectivity issues. And since we think that connectivity is so important, that's the reason why my colleague Aurora has prepared several slides that deal with edge computing, swarm computing, and also connectivity issues that are still a challenge that we need to consider in the IoT domain. Since collaboration and avoiding fragmentation is quite important, I also wanted to mention another initiative that is working partially on some of the aspects that have been mentioned today. And since I have mentioned particularly data economy and artificial intelligence, you know that there is a process now to set up a potential partnership on AI data and robotics. I'm personally involved in that from the side of the Big Data Value Association. And this is also led together with AI communities like Claire Ellis, Euro AI, and also EU Robotics. What is important here is when you go to the technology enablers for AI, basically we have created like 5 major boxes. All of them contain a lot of details. For sure, today we don't have time to go through all of them. But I think the important one for us today is basically this one that has been called sensing, measurement, and perception. And this is not just the vision of Atos, this contains basically the vision of the crowd, so the community around data. But I wanted to mention basically what we see as a challenge regarding this particular asset. Challenge, needs, or requirements, we could say. First one is trustworthiness. Second is capacity. Third is heterogeneity. Fourth is effectiveness. And 5 is scale. And I have highlighted in blue, particularly the second point on capacity, because I think that this really brings many of the challenges that I have mentioned before as part of the Atos vision. And also, I suppose that on the technical side of the discussions today, we will really tackle many of them. And going more in particular to those specific things, I would like to mention connectivity coverage, quality of data that has also been mentioned by Harald before. I think this is a quite important thing. Capacity for carrying large volumes of data, its capacity, and security to cope with decentralized big data and AI processing. And finally, as I mentioned before, the energy consumption by physical sensors. So basically, you see that there is a myriad of challenges. Some of them have been worked out in the past, still not solved, some of them, and many others are still ahead of us. And in our opinion, this has to do very much with making sure that we really have analytics and machine learning capacities within the devices. And with this, since we don't have a lot of time today, I would like to give the token directly to my colleague Aurora, and she will provide more review on edge computing, IoT, and 5G, 6G connectivity. So I hope this will be useful also following the discussions later on.
Thank you, Nuria. Perfect timing. Thank you. Now the floor goes to Aurora.
Thank you, Nuria. So if you stop sharing, I will share mine. Thank you. Check. Okay, can you see my screen now?
Yes, we can see it.
Okay.
Perfect.
Okay, then. Okay, so it's my pleasure to be here with my colleague Nuria. Thanks for the invitation. As I said at the beginning in the introduction by Nuria, I'm head of the Smart Networks and Services unit in Atos Research. So I will move now to tackle their relation, the vision of Atos in the relation of edge computing together with 5G, 6G connectivity, also IoT, of course, and its convergence. I will walk quickly through the edge computing basics. I think in this context of this event, everybody knows it has been also mentioned at the beginning, the benefits of edge computing. It's basically consists of moving the computing from the cloud to the edge of the network. So this process is closer to the user, closer to the devices. So we have benefits in terms of security, of reducing latency, and also lighten the load of the centralized cloud services, cloud servers, sorry. So as these benefits, as future networks are expected to provide, as we have seen for different scenarios in the previous session, zero latency communications, high capacity, this is more stringent requirements to support applications, new applications in the next years, like autonomous driving, connected car, etc. That means that edge computing capabilities will be a key fundamental technology, not only for IoT, but also for next 5G, 6G in the next years mobile infrastructure. This is basically because in the hyper-connected world that we will be facing in the following years, we take the view that the convergence between the infrastructure for mobile communications, 5G and 6G, and IoT should be a reality. Furthermore, future communications should also are expected to also offer high reliability, flexibility in this changing environment that is the edge of the network. So connectivity will have to include not only higher data intensity due to this high hyperconnectivity, but also to provide AI for network management, and of course the AI execution at the edge that Nuria has tackled. So this high relevance of edge computing is being tackled from different perspectives and different communities. Of course, from the data processing and IoT, from the cloud computing, now moving this computing to the edge, and also from the 5G mobile management perspective. Even from these three axes, we have multiple standardization bodies, multiple open source forums that now are becoming more and more agile, even going faster than the standards in many cases, and many industrial associations. I put that there just once, but of course there are many others. So the main message here is that if we want to avoid these potential fragmentations, we need to do an effort to converge technologically between all these communities. For example, from the more from the 5G mobile connectivity perspective, the key reference from the standards will be the multi-access edge computing. It was called previously mobile edge computing, that understand edge computing as the evolution of natural evolution of mobile-based stations as a convergence from the IT and networking world. Considering use cases, of course, one of them IoT.
Thank you very much.
The movement here now in research, sorry?
I wanted to say 1 minute left, more or less.
So that would mean 10 minutes for all for, sorry, Monique.
How long would you need, Aurora? Just I can decrease some other parts of
we were thinking in 15 minutes altogether, so
okay.
maybe other 7 minutes or so. Thank you for that. Okay, so I was saying main research challenges now for the multi-access computing perspective, integration with the core cloud part, and inclusion of AI-based automation. That means interaction with two key groups in our standardization, which are network function virtualization, that has tackled a general architecture for cloud resources where the network functions are deployed on, and HCNI that provide interfaces specification for the inclusion of AI. So an important effort is being done in that direction, but there is a lot of path still to follow. From the cloud computing perspective, the main research areas that we identified when moving to the edge computing are mainly new management styles due to the decentralization that has comes into the edge computing area. Second, those distributed setups that needs to include new mechanisms. Regarding the workload management, different encapsulations are needed because we are considering now not only virtual machines, but containers is a clear trend that is there, and hybrid management solutions coping with the different encapsulation approaches needs to be in place also for different kind of processors. Important challenge also the data abstractions that have to cope with very heterogeneous distribution environment. That means smart devices, sensor, mobile, everything. Volatility of the resources, that's a very important challenge for me regarding when we go from cloud to edge, because you know at the edge the nodes are moving, volatile, so the management should be different, and this has very important impact in the connectivity, important challenge in connectivity. And finally, the optimization when offloading between the edge and the cloud, and the integration between the edge and the cloud. So what we see next from Atos that comes into the place as an evolution from edge computing, because it tackles many of the challenges that I have just mentioned. And this is swarm computing. First, swarm computing combines network and cloud principles, so and creates a decentralized computing, something very, very important to cope with the previous challenges. Second, considers the various device typologies of multi-cloud architectures, what contributes to the challenge for this integration between edge and cloud. So solve two key current challenges: need orchestration with core cloud and the integration with connectivity. So this is what we are considering like a computing continuum, as you see in the picture on the right, which multi-cloud and edge cloud forms a computing continuum. And how this is done in swarm computing, but basically by means of dynamic ecosystem of multiple clouds that forms a collectivity. So it's kind of build a service network that enable ad hoc collaborations and are able to share and exchange information and services. So we gain in reliability and efficiency, and this means a significant step towards these massively distributed computing models that we are expecting in the following years. Finally, just to wrap up, main ideas that I have mentioned here is that, okay, edge computing is a key technology, as you know, for IoT, but the convergence also with mobile should be in place, because IoT and mobile infrastructure should be convergent as well, to be able to cope with this hyperconnectivity and all these stringent requirements that future applications will be demanding. That an effort to find technical synergies and, are needed in these different areas to converge, so we avoid fragmentation. I have explained different research challenges that we see from the edge computing perspective: decentralized, distributed setups, data intense, volatility. But
thank you.
Just to pay attention that, okay, we cannot take everything together. Yeah?
Yes, Aurora, we need to really speed up because we have 2 other speakers.
1 minute, okay? So we have limited resources in the edge, and we have constraints of cost and energy consumption. So from Atos, we see clearly a trend in swarm computing that brings a lot of potential, solving the integration with the cloud and with the connectivity in a collaborative environment. And just to finalize, sorry, just to show this final figure that comes from a report from Atos. Atos has a look that where we see swarm computing, of course, having high business impact, and the key technology from 2021 year and on as an evolution of edge computing. Thank you on the seat. Sorry, we thought we had a bit more.
Aurora. I need to pass the floor quickly to Omar, that will talk, Omar Elloumi from Nokia, that will talk about architectures, interoperability, and orchestration. Omar, the floor is yours. If you can stop sharing the screen, Aurora, so that Omar can take over.
Hi, Monique. Can you hear me? Monique? Monique?
We can hear you. All good.
All good. Okay. Thank you. Thank you for having me here. I'm Omar Elloumi. I work for Nokia. I'm also involved in AIoTI as a steering board member. I'm going to tell you a little bit about some of the challenges we see because we have ongoing projects pertaining to building edge infrastructure in conjunction of mobile networks. As you know, Nokia is a cellular network provider, and we are providing infrastructure to a mobile network. So the motivations for the mobile network operators to go to edge cloud are about demand on one side with industrial IoT applications, V2X, gaming, AR and VR applications. So the demand is here to stay. The mobile network operators have also a huge opportunity in terms of the points of presence that they can leverage right away in order to build infrastructure for edge computing, including with far edge and deep edge kind of setups. So we are speaking about even roughly up to 5 kilometers close to the users, and even closer to the users if we are in millimeter wave kind of scenarios, for instance. Additionally, 5G is just around the corner. We have features in 5G like ultra reliable low latency communications. We are typically speaking about few milliseconds of round trip delay. And if you build this kind of features, they will call naturally for complementary edge computing. Otherwise, you lose all the benefits of having those features. So we see the market ingredients are there for to build massively distributed edge cloud infrastructure and with time to market. So one legitimate question. So if cloud computing has existed for so many years, why deploying cloud at the edge makes things any different? So having a quick look at at the evolution of the cloud. So first, people start buying virtual machines. So you get the machine with CPU or GPU and memory. And with that, or you get a set of machines. With that, you build your application. Then things move to containers, which is an evolution of virtual machine. And then we are moving to orchestration clusters. So you get certain capacity, and that comes with attributes like horizontal scalability, no single point of failures, high availability, high throughput, low latency. And this is a very, very important point for, especially for IoT developers, because if you have a killer application which has market demand, you can build your cloud infrastructures with 5 to 10 engineers. That's enough. In the past, when we wanted to build systems with high throughput, very, very scalable systems, we need hundreds of engineers. And things are changing. So that provides a huge opportunity for garage startups in order to build IoT applications. And then things are moving serverless, which means that you don't even think about those orchestration clusters. You have APIs for data collection, for data storage, which means like you don't even care about things like scaling up and scaling down in order to cope with the load of your, which is generated by IoT. There are pros and cons in both approaches, but more or less, as time goes on, the entry point for developing applications in the cloud becomes lower and lower, and becomes accessible for developers. This slide provides some of the attributes that we are looking for cloud and then for edge cloud. So just to summarize, high throughput, horizontal scalability, which means the capacity to scale up and scale down, no single point of failures, low latency, which can be achieved by things like in-memory database and so on. And of course, this is where we see a role for edge computing and also security. This is providing a snapshot. So you see here moving up the layer from the infrastructure all the way to the orchestration. What's key about this? So we start having commercial grade software, which is open source, that can be used off the shelf, and that's accessible for everyone to use. And that's I think that's very, very key, because it helps the developers to build prototypes and deploy them in almost no time. I will skip this slide. Now, when we go to edge computing environments, and when we go in particular for mobile networks, we come across a certain number of challenges that we need to solve. So the first ones are pertaining to discovery and routing of the traffic. So if you have applications running on devices, you need to make sure that you discover the optimal edge cloud that will serve your application client. And the optimal edge cloud, it means it has the necessary resources like CPU, GPU, and it needs to provide the lowest network latency. Then, because of mobility, we need to figure out how to deal with service continuity, which means if I have a mobile device, if I get served by an edge cloud which is in Paris, and I move out of Paris because I have a V2X applications, I need to make sure that I still have service continuity, which calls for coordination between applications deployed on different edge clouds. It's another challenge. I will not go through all of them, but one thing that seems to me extremely important in this discussion, which is edge federation across MNOs. This is extremely important because if we ensure that the mobile network operators offer the same capability, the same APIs, and the same features, which means that an application built for, say, Vodafone can still work on Orange Cloud. That's extremely important because this will call for eventually a pan-European cloud infrastructure based on MNOs, and it allows for application portability. This is something, for instance, that the GSMA is busy with at this point in time. And then, even though cloud has evolved mostly under open source, etc., we see a role for standards body to play, because in all the scenarios that we are talking about, we have multi-stakeholders, users, MNOs, cloud provider, application providers, and there is no single vendor that makes everything, who can make everything. So there are the device vendor, the applications, the infrastructure, and so on. Some of those issues that I have been talking about are being dealt with in EDC, multi-access edge computing. I think EDC did provide the foundation standards for edge computing, for in particular with initially with mobile access, but now it's evolving to multi-access, so any access. Things also are evolving in 3GPP in conjunction with 5G. And there are some other organizations setting up the scene, like 5G AA, which is doing automotive, and GSMA, this notion of federation. I will skip this slide. This is providing a snapshot about the work of GSMA. So GSMA is the Association for Mobile Network Operators, where they have this operator edge platform. And in the phase one, the purpose of this work is to federate multiple operators' edge computing infrastructure to give application provider access to global edge cloud to run innovative, disruptive, and low latency services through a set of common APIs. So it's different deployments, but seamless user experience and seamless application experience. That's their value proposition. This is another slide from a white paper that we published recently on harmonizing standards for mobile networks. I will not go through the details, but the value proposition. Yes, Monique?
Yes, maybe how long do you think you still go on? Because
1 minute.
Okay, great.
So I put a link to this white paper in a previous slide, but the value proposition is to run anywhere up. Oh, this is a copy-paste problem. The value proposition of this is to address all the challenges that I listed before, which is discovery, frequent mobility for V2X applications, for instance, and federation. Concluding remarks. So edge computing inherits all the attributes of cloud computing, like horizontal scalability, scaling up and scaling down, no single point of failure, and so on. There are certain constraints pertaining to resources. And I spoke about shifting or service continuity, where you need to shift the application level context from an edge cloud to another edge cloud. But you could equally be forced to do this service continuity because of constrained resources on certain edge clouds. There are new challenges that have been solved or under the process of being solved by standards. Those are pertaining to mobility, routing, context transfer, federated platforms. And since we are moving up the layers, and we spoke about this evolution towards serverless, etc., but then one possibility, if we are in a federated approach of edge clouds, is also to support features pertaining to data space and data sharing as we evolve the cloud features. Thank you very much, Monique.
Thank you, Omar. Thank you very much. Very dense of contents. I apologize. I have this role today of keeping time. Not always easy when presentations are so rich and dense. I would like to ask my colleague Verena to please shoot the next question in our poll. What are the most challenging aspects related to the edge IoT paradigm shift from a technological point of view? You have heard a few already insights into technological challenges, technical aspects, and I think you can now see that the choice, it's about decentralizing and distributing intelligence, computational capacity, essentially, guaranteeing connectivity, protecting data, or any other. It would be great if you can share your input on this front. And now I would leave the floor to Ilkka for his presentation. Ilkka sorry, I give for granted that everybody knows him. Lakaniemi is from Combient, and he will talk us about demand, supply, and regulators. Thank you, Ilkka.
Thank you very much. If you can hear me, I'll switch on my presentation. I only have 3 slides, so trying to be efficient there. Let's see. There we go. Does it show?
Not yet.
Huh. Try again.
In case I think we have, now yes, now it should work.
Okay,
Something's coming.
Good.
Yes, perfect.
So it was the talking about the shoemaker and the shoemaker's shoes and all that type of proverb. But basically what I would like to continue from here is that I think I represent in this session the user perspective. So what it is that Combient, the companies that make Combient, are actually looking for when you talk about IoT, when you talk about data, when you talk about edge computing, all of these together. And I think what was mentioned previously about the convergence of technologies, that's exactly the viewpoint from the company's side. So for those of you who don't know what Combient is, the name comes from combined entities. So the industry network of the following companies. So primarily Nordic companies residing in Sweden and Finland, and all of them being leaders in their own fields. And what it is that they are currently doing is that they really look for that what is the business case or what are the use cases for using the different technologies in their business operations, and how in some instances you can do a kind of a cross-sectoral interactions and cross-sectoral cooperation by using the same technologies for use cases that are beneficial to many companies at the same time. So we're not only talking about how, for instance, a manufacturing company such as Atlas Copco can get benefits to optimization of existing business processes, but basically how, for instance, companies like SAB, which is a bank, and Husqvarna that makes chainsaws and lawnmowers, can actually come up with new type of business models altogether based on using the data, whether it's stemming from the sensory data or any other sources for the data as such. And our viewpoint clearly is that whatever that business case is or use case is, we will then start looking for the technologies that make most sense for that purpose. So we arrive from not from the technology point of view, but really working on that. When we identify a use case for an individual company or a group of the companies coming from the Combient network, we will then look at what are the technologies, be that, for instance, edge computing, can be already used for their specific purposes. And one of those cases that we are currently looking into is that where the sensory data and connected products are increasingly used. And most of you know Kone, that makes the elevators and the lifts. So they're currently working on a smart platform for buildings and the people flow. So the people within the buildings and be there as residents or customers or whatever, but basically what type of data is being produced, how the consumers or the users themselves can influence that utilization of the data, and what are the type of data platforms that you need to have in place in order to manage the data flows and at the same time to manage the issues that are related there from the regulatory point of view, whether it's the GDPR or other areas as well. And then we have companies that are very much heavy industry companies like Scania that makes the trucks, and I'll take, for instance, Stora Enso and Södra that are forestry companies, that in their optimization of the manufacturing processes, how the sensory data and the use of edge computing, for instance, helps them to become more efficient, and where they can have productivity enhancements with the existing workforce. And when you go into the actual doings or tasks that we are currently doing, you can utilize this type of a picture that, as I said, we derive everything from the business models that we see where the data insights or the data can play a role. Then we are looking into, in the case of edge computing as well, we're looking into that, what is the role specifically about the quality of the data, what data there actually is, and whether that data can be shared in a meaningful way, and what is the value add if it's being shared. There are regulatory issues related to that. Most recently, for instance, we have been not struggling, but working on the issues that how here in Finland we have come up with guidebooks for the ethical use of data and also the ethical sharing of data. And we are currently implementing many of those guidebook ideas and guidelines into our work. The one thing that I would like to highlight here is that when we talk about technologies and the implementation of that technology in your companies, we're sometimes lacking maybe the perspective on skills, so the talent and the ways of working that need to be changed within these companies. And in our case, we are putting quite a lot of effort on that. So not only thinking that what are the type of technologies that we will be needing, but also what are the capacity and what is the maturity of the companies that we have in our network to utilize and to implement the data-driven new businesses, or starting from pilots to the overall implementation of using that. So we do quite a heavily skills development in order to have the existing workforce to be able to utilize the new technologies. And increasingly, I have to say, we do it in a way that it's being customized for the companies and stemming from their perspective where that makes the most sense. So instead of working directly with the big vendors, we are actually creating our own best practices, and based on the best practices, coming up with the kind of the shared models, or whether that's in machine learning or elsewhere, that can be then utilized by the whole network. So that's primarily the area where we're currently working on. So in that sense, I'll leave it for your discussion, because I think we're running a little bit out of time, but I'm very happy to take any questions related to what is the actual business value of using the technologies and the data in different areas. Thank you.
Thank you. Ilkka, if you can, thank you. So now I would like to have the second question of the poll that we prepared, and then I have, given that we're about to finish, I would like to call back the various speakers. So what is the way ahead? Well, that's, sometimes when we put together questions for polls, it's not easy, but we need to simplify a little bit. Definitely, there's a lot of work that needs to be done along several paths. Standardization, we have heard quite a few of you talking about that from a more technical perspective. Regulation, we know that Europe is not one unique country, is a country of countries, is a rather complex reality in legal terms, also for what concerns deployment of technologies that might cross borders. Policy making that relates very much to regulation, laws, and any other. So please express your opinion here. And now I would like to pick up on something that came up to my eyes when looking at your slides, and that is a sentence that is edge computing inherits the attributes of cloud computing. And and this is a technical statement, right? Do you agree or do you rather disagree? And I'm asking Aurora in particular. She has more of a technical take on this, and I think is related a little bit also to the question. The sentence was in one of Omar's slides.
Well, I agree, but to some extent. Okay, we can come from cloud computing perspective to edge computing, but of course we have many different challenges that is different from edge to cloud. As mentioned, one that I think is very important is the volatility of the resources at the edge, for example, that brings up many connectivity problems. Because you know, at the edge are moving, so yeah, that would be for me one of the key challenges. There are others, but okay, we kind of hit it, but a lot of work should be done from the research perspective still.
Sure. Omar, are you there?
Yes, I am.
There's a lot of, I mean, especially your slides were very dense also in terms of, you know, linking to what are the main challenges in terms of connectivity. There's a lot of debate on you know, 5G connectivity and 5G networks as being part of the picture. How do you, I mean, a critical comment on you about deployment of edge versus deployment of 5G?
Deployment on edge versus, I don't know why you make a difference between deployment on edge versus deployment on 5G. You mean deployment?
What I'm saying is that while there are quite a few scenarios that are already, let's say, based on edge computing and do not necessarily rely on 5G, what's going to be the big change when 5G deployment will start to be more extensive in terms of edge computing? What's going to be the impact?
Okay. Deployment on edge are happening, but they are not happening big time. I think that 5G will drive the mainstream deployment of edge computing. That's the first point. Second point, if you take scenarios like factory, for the time being, the factory are by definition edge enabled. So they have their edge infrastructure, and they have been having edge infrastructure for ages. The same thing in substation, and someone spoke about energy. They have been edge cloud since years and years, since 25 years. The challenge is, and what we are looking for, if we will see if 5G will bring new perspective, and potentially packaging the edge computing with 5G will bring new opportunities.
Thank you very much, Omar. One quick question for Nuria. Clearly, data at the end makes the difference. Data at real time for many critical applications requires not only local storage capacity, but also computational capacity, and in a way, a sort of lightweight AI to be at the edge. I know that Atos, but also BDVA, in which you guys are very active, has been exploring quite a few aspects there. Can you tell us what you think are the main challenges along that direction, bringing more intelligence to the edge? We cannot hear you.
I was muted, sorry. I think that in one of my slides, I pointed out some of the challenges that have already been highlighted in the context of data. And many of them have to do with dealing with data heterogeneity, but also energy consumption, privacy. So I think that I have mentioned several, in fact.
Okay, thank you very much. I would now.
One of the things, Monique, just if you allow me, because I think that that was mentioned in the beginning of today, but we didn't go very much into detail on that. One of the things that we always get as feedback from the community is the lack of a suitable infrastructure at European level. I think that is common to many of the technologies we are discussing today. And someone mentioned before this Gaia X initiative that maybe can be like a way to solve this problems. We'll see it if it will happen in the end, but I think that is also a quite important aspect because it's not just a purely technological thing. I think it's also a business problem, as was mentioned also by Ilkka and some others. And one of the things we want to have is really sovereignty. So this means also using, having the data in Europe, making sure that we have the right infrastructure at European level. And that was not the case so far, or at least stakeholders are not using our European infrastructure. They are using that coming from other companies, mainly from Asia and from America, as you know very well. And these impacts cloud computing for sure, edge computing, but also something that was mentioned in the chat and sometimes is needed in some use cases like high performance computing and other kind of infrastructure. So finally, everything will depend very much on the kind of use case you have, because this will bring different needs and requirements. And what it is important is to have a federation that allows you flexibility and also a good offering from a business point of view in order to be able to manage all this data. So we are not talking just about the devices, making them smarter, but I think that this aspect of having a truly trusted European infrastructure that can serve the different kind of companies is very important, because if in the end we depend on infrastructure coming from other stakeholders, then we are really solved, because data will be there and all the processing capabilities will happen there.
Thank you very much. Thank you also to the audience, because I'm reading through the comments, the points that are made about, relevance of high performance computing to the edge, obviously, and also about the fact that there are already some technology provider, big tech provider, that essentially move data to the cloud data center, which of course it's not always an option, Mark. That's also why several there's quite a few more and more smart devices for different kind of usage, especially in industrial IoT, that are exploring in which way you can have this lightweight AI at the edge or data analytics at the edge. So I will read through the comments very closely, but I would like to now break. It's 12:39. We're supposed to stop at 12:30, but I would like to catch up on the delay so we don't delay the afternoon. So thanks a lot to Ilkka, to Nuria, to Aurora, and to Omar for this very interesting second session. And we meet at 13:15, same channel, same virtual room for session 3. For the people that will leave us, have a good afternoon, a good weekend, and thanks for being with us until now.